I picked up this little interesting relay. I know relays aren't particularly interesting normally, but this one is. This one has some features that aren't probably that well seen in relays. It's a very large relay, as you can see. It's usually relays, just a solenoid and a contact switch here. But what's interesting right away is the length of throw of that switch. That has a very large movement for the contacts which are buried in here. And that made me wonder, why would you do that? Because most relays don't have that length of travel. And then I spotted something interesting. There's also a magnet placed on either side of this little chamber. You can see a magnet on each side, and that's where the contact's buried inside that chamber. So this turns out to be a relay designed for breaking DC circuits. There's a problem when you try and break a DC current because the voltage or the current isn't passing through zero. When an arc forms, it's much harder to break that arc because it will try and continue, and with the ionized arc can be dragged out quite a distance. So to do that, you really have to make the arc path as long as possible. So the long throw certainly helps there. But the addition of the magnets introduces some basic school physics, and that is that the current flowing through that arc will be influenced by the magnetic field and forced. If it's wired correctly, this is forced the arc out this side. So the arc will travel in a kind of U-shape to come out here to the point where it will rupture and break the circuit if an arc forms. If you wire the relay the wrong way around, the arc will be forced into this side of it, and you will get the arc forming into the components of the actual movement part. And I tried it. You can see a little scorch on this area here, and a little scorch at the top where the arc is blasted out at the back end of this. So with the correct current flow, the blast will go in through this part and be held inside the chamber here, or come out at the front here safely. So for the setup, we have a Variac applying a bridge rectifier into these two large capacitors. So I've got a very large smoothed DC voltage through a coil here just for a bit of inductance, and the relay, and then the load is a 300 watt resistance. Rather than using an open arc to demonstrate this, I'm using a very old Geissler tube which has an ionized gas inside representing the arc discharge. So if I bring a magnet up to this, we can deflect that the same way as we do in the relay. So if I bring up the North Pole to this, now this is a DC beam. I've got this travelling in one direction, so you can see the beam is deflected in one direction, but it's extending the beam path, so this should aid or increase the resistance and create a rupture for it if it was in the relay situation. Represent what's going on in the relay. I've drawn two terminals here, and we shall indicate what would happen with an arc. The blue line is representing our current flowing through the circuit, so we've initiated an arc, and with that arc will form, like in any wire, will be a magnetic field. Associated magnetic field generated by the current in the arc flowing in the direction from the top to bottom of the image, showing field lines appearing. If we have magnets at either side of that, then that will influence what's going to happen. Now with the magnets either side, so we've got north and south poles of a magnet creating field lines across the arc and interacting with its own magnetic field, the result is for the forces to act to push that towards the camera, basically. So that should be pushing out of the image here towards us, forcing the arc to take a longer path. So the net force is to push this arc out towards and make the path longer. So So a really interesting idea, and this has kind of reappeared actually in some relay manufacturing with the advent of electric cars and things where you have large DC currents and voltage to be broken, which does cause a big problem for switches. We found that kind of quick and interesting. Thanks for watching.